Suppose I want to evaluate this integral, the integral of 2 times the quantity x minus 6 to the 3/2 power. And suppose I want to do it by the guess and check method. What you have to remember is guess and check involves guessing the antiderivative, the integral, then checking your guess. If it matches exactly, then your guess is the answer. If it's off by a constant factor, just a numerical value, you can adjust that in your guess, we'll call that the adjusted guess, by using the reciprocal of what you're off by. Then check that solution by taking its derivative, making sure it matches the original integrand. If it does, then that's the answer. If you cannot get a match within a constant, just a numerical value, then guess and check doesn't work. In general, we're going to be using guess and check on the easier of these problems in any case. So you always have other choices. We're going to be, generally speaking here, using the general power rule for integration as our model for our guess. And the reason is, when you have an integrand raised to a power, the general power rule for integration tells you that the solution will have a power 1 higher than the power in the integrand. So when I'm doing this problem, I'm going to guess that the integral will have a solution with a power 1 higher than 3/2. And of course, 3/2 plus 1 is 3/2 plus 2/2, which is 5/2. My guess will use that as the exponent. And before I actually get started on this, let's copy it down here. So as I said, my guess for this integral solution is going to be the base raised to the 1 higher power. Notice there's a 2 there. I'm going to carry it with me for now, but just follow along with me. My guess has to be checked. How do I check the guess? By taking the derivative of it. Okay, by the power rule, you multiply the exponent times the coefficient. So you get 5/2 times 2. Write the base down. Reduce the power by 1. 5/2 minus 1, which is 2/2, would be 3/2. And then multiply by the derivative of the base, which in this case is 1. If you simplify that a bit, the 2's divide out here, and you get 5 times 1, you get 5 times the quantity x minus 6 raised to the 3/2 power. Does it match the original integrand? And if you look back, it doesn't. Part of it does. The part that has a variable in it does. Notice you get all of that, but the constant is not right. This has a 5. This has a 2. So it did not match exactly. That doesn't necessarily mean that guess and check failed, because we only differ by a constant. If you differ by a constant factor, you can adjust. Now we'll suggest this. If you have a constant in the original problem like this 2, and it doesn't work out exactly, we got a 5, we needed a 2. If it doesn't work out exactly, I would suggest going back to the general power rule formulation. This a in the formula is like the 2, and I would suggest taking that a and moving it outside the integral sign. We're allowed to do that. We can move a constant factor outside the integral sign. So whenever the initial guess doesn't check exactly, but it's only off by constant, my suggestion is to rewrite that integral with the constant outside of the integral sign before you continue. So what's going to happen is we're just going to leave the 2 and ignore it until the very end. We're going to work the problem without the 2 in there and then multiply our final solution by 2. So now we're going to make our adjusted guess by ignoring the 2 outside for the time being and just looking at the integral I have boxed in up top there. So I want to guess this time that I'm going to have the x minus 6 to the 5 halves, which is what the general power rule of integration tells me. But because I don't want the 5 halves to show up in the answer, I want to multiply by the reciprocal of that, which is 2/5. So my adjusted guess for the integral in this box up here is going to be 2/5 times the quantity x minus 6 raised to the 5 halves power. As long as I move the 2 out and don't worry about it now, my adjusted guess is always going to be the reciprocal of the power. So if I have 5 halves, it'll be 2/5. If I have 9/5, it'll be 5/9. If it's 5, it'll be 1/5. You're always going to make your adjustment as the reciprocal of the power you're guessing. And now we'll check it. Let's see if that's right. In order to check it, we take the derivative. The derivative is the power times the coefficient. That's 5 halves times 2/5. Write the base down, x minus 6. Reduce the power by 1. The 5 halves minus 1, which is 2 halves, becomes 3 halves. And then you take the derivative inside, which is 1. Notice that 5 halves times 2/5 is always going to be 1 because you're multiplying by the reciprocal. And that's the whole reasoning behind what our guess is for the adjustment factor. And you end up with the quantity x minus 6 to the 3 halves as your adjusted guess check. Now the question is, does it exactly match the integrand? Remember, we're looking at the integrand in this rectangle up here. We're just ignoring the 2 for now. And if you notice, it does match exactly. Look, this and the integrand exactly match. That's an exact match. If you get an exact match, then your adjusted guess is the answer. So that means when all is said and done, remember the 2 is just sitting there. So I want to keep it there. It's 2 times, this 2 is just sitting there, so I have to include it here. 2 times my adjusted guess. Well, what was my adjusted guess? My adjusted guess was 2/5 times the quantity x minus 6 to the 5 halves. Now you always have to put a plus c on the end of any of these indefinite integrals, because if you think backwards, the derivative of any constant is 0, so there could be any constant term added on. You don't know whether it is or isn't, so you put a plus c. And simplifying it one more time, if you multiply 2 times 2/5, you get 4/5. And I'll put the final answer up top here. So you end up with 4/5 times the quantity x minus 6 raised to the 5 halves power plus the constant of integration. And you solve this problem by guess and check. You can solve it by one of the other methods, but for the simpler ones, you might consider this guess and check. If you don't like it, you don't have to do it this way, but at least you want to look at it and consider doing it this way, at least for the simpler problems.